Hello beautiful people and welcome back to the channel, the go-to spot for all things data engineering interviews. If you are new here, make sure to hit that subscribe button and ring the bell to stay updated with all our latest content. Today, we are going to dive into a very crucial topic that every data engineer should master. Yes, PySpark. So if you are preparing for an interview, then this discussion is for you. So let's get started. Now, usually whenever the interviewer starts asking the question, I have seen like they will be asking the real-time problems. So what are the real-time problems you faced and how did you address it? So whenever we run any Spark jobs, like usually we would have seen like many types of problems ranging from like out of memory issues, slow performance, insufficient shuffling, data skew problem. So whenever any PySpark job runs out of memory, it can lead to crashes or like poor performances. So this issue typically arises due to a few common reasons related to how resources are managed and how data is processed within the Spark environment. So understanding these reasons like can help in optimizing a Spark application to prevent out of memory issues. So when we talk about the out of memory error, right? So there are various reasons. Just now we spoke about why we are getting it. So it could be due to like inadequate executor memory. So each Spark executor has a certain amount of memory allocated to it, which can be set using spark.executor memory in the configuration parameter. So if you want to increase those memory, you can always like set those memory into the configuration. Here we can see the spark.executor memory and spark.driver memory. So we can play around setting this memory allocation. So this will be the first step. But again, this might resolve the problem, but it will not address the underlying issues. So be mindful before changing any configuration to executor and driver memory. Now, second thing is optimizing the data partitioning. So how data partitioning helps like coming out of memory error issues. So optimizing data partitioning in Spark is very crucial for improving the performance of distributed computations, and it will ensure the efficient data distribution across the cluster. And good partitioning basically helps minimize network IO and balance the workload evenly among nodes and reduce shuffling. So there are a few strategies to optimize the data partitioning in Spark. So we can follow those things. So basically choosing the right number of partitions. So by default, like Spark tries to use a reasonable guess for the number of partitions based on your cluster. However, you might need to adjust this depending on the size of your data and memory capacity of your nodes. But usually what I have seen is we are adjusting partitions manually. So you can manually set the number of partitions using like repartition or coalesce, can increase or decrease the number of partition and involves a full shuffle of the data. So, and coalesce is like used to decrease the number of partition and tries to minimize the data movement. So this is all about the optimizing data partitioning. Now we have to enable dynamic allocation. So dynamic allocation allows Spark to adjust the number of executors dynamically based on the workload. So this is also very it plays a very crucial role for the performance. And we should not forget about the long GC, garbage collection. So whenever we see any long garbage collection, so we will see the performance issues in those scenarios as well. So we can change the configuration I have given here. You can use use GIGC in like Spark executor, extra Java options, and Spark driver extra Java options. So we can play around with GC settings as well. Now coming to slow performance. So slow performance can be due to various reasons like complex data processing. We should always avoid using of collect method, or instead we should use like take method or first method or for each method. Those kind of small approaches we need to take whenever we are coding. So that thing you can tell regarding the slow performance. And for insufficient shuffling, right? So when data is not partitioned correctly, so in that scenario we have to use the repartition or coalesce, as I told you in the case of out of memory error as well. So everything are like interconnected. Not only with the case of out of memory error we could be the reason for insufficient shuffling. So all these things are interconnected, and we should address it like in one go. Also you can do it. Now coming to data skew. So we know like when data is not evenly distributed across the cluster, so we see the performance issues. There will be like a slowness in the job execution. So here in the graph you can see like when data is not evenly distributed, on the right hand side we can see like the skew data. So all the nodes like they do not have the evenly distributed data. So this is like very crucial, and if this happens we can address this with the help of bucketing. So data skew can be addressed with the help of bucketing. We have to use bucketing to evenly distribute the data. Now I have given a small example here where we are redistributing the data across the cluster. So here you can see, right? So we have here a sample data frame, and we are writing that data frame into a bucketed format. So we are specifying like how many like number of buckets we should be having, and the column name on which we will be doing the bucketing, and then sorting each bucket with the column name. But again that is optional, and again we will be saving it as a table. So this is a very small example. So certain things we have to consider here. The choices of column, right? So the column which we are choosing for bucketing, right, should be one that will be like frequently used in our joins or like any group operations. So this will like the effectiveness in mitigating this data skew depends heavily on how evenly distributed the data is in the selected column is. And second is the number of buckets, right? So the number of buckets, like it should be not too low, not too high. basically to avoid too few overly large buckets, or like too high to avoid overhead from too small buckets. So, and use with partitioning. So bucketing, like it can be combined with partitioning for even finer control over data distribution. So any fine grain level column, like the date type, can be used for for the partition. So this is a very important topic, data skew, and how to address that. So this is commonly asked question in PySpark interview. So yeah, make note of it. Moving on to next question, very common questions, the PySpark architecture. So in many interviews, like they will be asking how PySpark architecture, explain the PySpark architecture. So this is a very in short, I will be explaining it. So we should be on the left hand side, on the right hand side, you can see we have the driver program, which is basically the input of our Spark job, and the Spark context we can see here. So these names we have to remember: driver program, Spark context, what is cluster manager, executors, tasks, task schedulers, DAG schedulers, stages, jobs, results. So if you remember these terms, it will be like easy to explain each thing. So when we talk about the driver program, so the driver program is where your main application runs. So it is responsible for initializing the Spark context, submitting various parallel operations on data, and delivering tasks to executors to be run. Coming to Spark context, so at the heart of any Spark application is the Spark context. So it connects to the Spark execution environment and is responsible for converting your application into tasks that can be distributed across the Spark cluster. So in Spark, the Spark context is established at the start of any application and coordinates the process. Now, coming to the cluster manager, what is cluster manager? So basically it allocates resources for applications across the cluster. So several types of cluster managers are supported by Spark, which includes the standalone, which is a simple cluster manager included with Spark itself. We can use Apache Mesos as well. This is a general cluster manager that can also run Hadoop MapReduce and service applications. Then we have Hadoop Yarn, so the resource manager in Hadoop 2. And we have Kubernetes as well. So an open source system for automating deployment, scaling, and management of containerized applications. So I have seen Kubernetes is now being used widely for the containerized applications using Spark. So this is a very on a high level I'm explaining. Now coming to the executors. So basically executors are distributed agents, and they are responsible for executing the tasks assigned to them by driver. Each executor is a separate JVM process, right? And executor perform the computation and store the results in memory or disk. So data stored in executors can be reused in other actions. This is what allows Spark's caching and fast execution. And now we have DAG scheduler. So DAG scheduler basically divides the operator graph into stages of tasks. So a stage is like comprised of tasks based on partitions of input data. So the DAG scheduler pipelines operators together to like optimize the workflow. So that is what DAG scheduler is. Now coming to the task scheduler. So basically it launches the tasks via cluster manager, and task scheduler is responsible for sending tasks to the cluster, retrying if failure occurs, and also like mitigating any bottlenecks. So task scheduler plays very important role. Now coming to the job. So basically a job is a parallel computing consisting of multiple tasks and getting spawned in response to a Spark action, like whenever we are calling any collect method or save method, right? So it will get triggered at that time. So basically on the action. And coming to the stages, so jobs are basically divided into stages. Stages are classified as sets of tasks that perform the same computation but on the different partitions. So stages are separated by operations that require shuffling the data across tasks. And what are tasks? So tasks are the smallest unit of work, we can say, and they are sent to the Spark executor process, and each tasks work on a small unit of data. That is how distributed computing works, right? And so yeah, so these are the like major components of the Spark architecture. So if you explain all these things, that is quite enough. And regarding the data processing and the usage of Python and JVM, those things like also we can tell in Spark, like we have the RDD and the data frames, and they are the primary data structure, and operations on these data sets are automatically parallelized across the cluster. So we can explain those things as well. Now the next topic is repartition versus coalesce. So this thing has been asked to me like various times, and I was asked the scenario as well, like in which scenario like did you use the repartition and which scenario did you use the coalesce. So we have to understand how, like basically in Spark the repartition and coalesce method are used to adjust the number of partitions in a data frame or on an RDD. So these methods are crucial for like optimizing the performance of a Spark application, as we discussed earlier, especially by improving the execution efficiency of transformation and actions. So let's understand the repartition first. So repartition is used to increase or decrease the number of partitions in data frame or RDD. So this method can shuffle data across all nodes in the cluster, which means that it can cause a full data shuffle in the new number of partitions is greater than the current number. So the usage is it is typically used when you need to redistribute your data evenly across the cluster. So here we can see in the example we have blue, red, yellow and green. So they are all jumbled and sitting in a different partition. So when we run any job on these partition 1 to 4, our process will be much more slower, right? So to avoid those things, we have to repartition the data based on the color. So here we can see we are creating like 2 partition, and each partition has like blue and red, and partition 2 has yellow and green, right? So this is we are achieving through repartition method. And and this is typically used like when we are redistributing the data evenly across the cluster. So by using repartition, we can achieve this, and which will be like helpful before performing any operations that like benefit from a high level of parallelism, like such as like reduce by key, right? So this would be very beneficial in those scenarios. So the repartition is the method, and we directly can call repartition method on our data frame. So you can see here a very small example dot repartition with 10 partitions we are making. Now coming to coalesce. So coalesce is basically used to decrease the number of partitions in a data frame or RDD. Unlike repartition, coalesce avoids a full shuffle of data. This is a very important key, and interviewer will be expecting like this is the main difference. So it avoids the full shuffle of the data and attempts to minimize the movement of data by combining existing partitions. So this makes coalesce like more efficient than the repartition when especially we are reducing the number of partition, right? So even in the upper diagram, like we instead of the repartition, we can use coalesce as well, right? So but the main the feature of like coalesce is to reduce the number of partition without shuffling the data. So here we can see we have 4 partitions here, and all partitions have got different colors, right? So we are making a single partition for each color. So this will be done through the coalesce, and the example is very simple. Just like repartition, we will be calling it on data frame with the coalesce method. So what are the main differences like between the repartition and the coalesce? So interviewer will be like mainly he will be interested in the differences. So coming to shuffling, so repartition can increase or decrease the number of partitions and involves like full shuffle of the data, potentially redistributing it across all partitions. But coalesce, it primarily reduces the number of partitions and does so more efficiently by minimizing the data movement. It does not require a full shuffle. Now coming to the performance, so repartition is like more computationally expensive due to the full shuffle. It's more flexible when an even data distribution is required. Coming to coalesce for the performance is more efficient for reducing the number of partitions since it minimizes data transfer. Now the use cases, in which use case like we will be using the repartition, in which use case we will be using coalesce. So when data needs to be distributed more uniformly, especially before a large shuffle operation that benefits from parallelism, right? So in that scenario, we will be using repartition. For coalesce, when you want to decrease the number of partition, like post filtering or any operation that results in a skewed distribution of data across partitions. So use wisely repartition and coalesce. So understanding like when to use repartition versus coalesce like is key to managing performance and optimizing resource usage in Spark application. Yeah. So moving on to the next topic, have you used Catalyst Optimizer in your project? So Catalyst Optimizer is it's a key component of Spark, which is responsible for optimizing the execution of queries. So It's an extensible query optimizer that performs a variety of rule-based and cost-based optimization techniques. So here is the overview of how the Catalyst optimizer works. So in Catalyst optimizer, it uses a tree-based architecture, and basically to represent queries, which allows it to apply optimization rules in a modular way. And the process involves several phases. So first is the analysis phase. So Catalyst analyzes the query plan to resolve references to data frame or data set operation. It checks for errors and applies logical rules to simplify the query. We have then logical optimization. Basically, it optimizes the logical plan by applying rule-based optimizations such as predicate push down, constant folding, and the Boolean expression simplification. And the physical training. So the Catalyst generates the physical plan for the optimized logical plan. So it uses cost-based strategies to pick the most efficient physical plan based on the statistics about the data. And then we have the code generation. So finally, the Catalyst generator efficient bytecode compiled Java code to run on each machine. So this step is crucial for achieving high performance in data processing. So this is a small example, and Catalyst optimizer is beneficial in case of debugging. If you have a slowness in your job, so you can easily debug through this, and this will be done through calling the explain method. So it will show you all the the steps and the execution steps basically, and you can check it out. And one more thing, coming to the use case scenario, this Catalyst is particularly beneficial in complex data processing scenarios involving any large scale data transformations or aggregation engines. So common use cases I have seen iterative machine learning algorithms, where machine learning algorithms often require multiple transformations and aggregations on the data. So Catalyst can optimize these operations by minimizing data shuffling and applying transformations in the most efficient order. And even in the ETL operation, so any ETL jobs where data is read from a source, transformed, and loaded into a target system. So Catalyst optimizes the transformation steps to ensure the efficient data processing. Now, coming to this example, let's consider this scenario where you have sales data, and you need to calculate the total sales per region with a filter on the year, right? So this code is for that. And here how you might write this in the Spark, and how the Catalyst would optimize it. So optimization by Catalyst. So if you run this, so it will explain you what are the execution plan, and the predicate push down, right? The filter column on the year is pushed down to scan only the relevant rows, reducing the amount of data shuffled during group of operation. And Second thing is like column pruning. So only the necessary columns like region and sales are fetched, and ignoring others that are not used. And the physical planning is that Catalyst might choose to use a hash aggregate for the group by operation if it deems it more efficient based on the the data statistics. So this example shows how a straightforward data frame operation like benefits from the underlying optimization performed by Catalyst Optimizer, so resulting in a faster and more resource efficient query execution. So this explain method, right? So basically, explain method is in PySpark. It is used to print the execution plan, as I said, of a data frame. It will have all the detailed steps that Spark takes to execute the query, and the true parameter in the explain method enhances the output by like providing additional information about the plan. So yeah, this is pretty much about the Catalyst Optimizer. Now, what is DAG? So DAG is, we all know, like directed acyclic graph. So basically, it's a fundamental concept that represents the logical execution plan of any Spark job, and it describes the sequence of transformations and actions to be performed on the data. So when you perform transformations on a data frame or RDD in Spark, such as filtering, aggregating, or joining, a logical execution plan is created, and that plan is called as a DAG. And this plan is then optimized by Spark's Catalyst Optimizer to generate an optimized physical plan that takes advantage of various optimizations and parallelism techniques. So to visualize the DAG of your Spark job, you can use the explain method on a data frame on RDD, and it displays all the execution plan in a tree-like structure, showing the sequence of operations and their dependencies. So this is not frequently asked, but yeah, sometimes it will be asked, so you can explain this. Now, another question I was asked related to the transforming column to rows, basically unpivoting thing. How will you achieve it? So I was asked once, like suppose like you have a table with column as ID, feature 1, feature 2, feature 3, and we have the values. You can see like ID 1, 2, and feature 1, 2, 3 has got their own values. Now I want to transform this into so this will be our input table, and we want the output should be in this format. The below table is the output. So simply we are converting, basically we want to convert columns to rows. So how will you achieve this? So this question was asked to me once only, but at that time I could not answer it. So later on, when I studied like how to do the unpivoting, so I came to know like, yeah, we can do unpivoting through Spark. And so this is the example so where we can do the unpivoting. So basically, to transform like data frame from a wide format to the long format, oftenly referred as a melting or like unpivoting in the data manipulation. So we can use Spark's select and explode and array zip function. So this approach is basically useful when you want to convert like multiple column values into a single column with the corresponding identifiers. So here is the you can see the code, right? So the array zip method, so this function basically combines the multiple columns into a single array of a struct, where each struct contains element from the respective positions of the input columns. Then we have the explode method. So this function is used to turn each item in an array column into a separate row, effectively expanding the array into multiple rows and one of each element of the array. We have the lit method. So this is used to add the constant values to the data frame, which are necessary to retain the feature names after using array zip. So this approach allows you to dynamically handle transformations from wide to long formats, which is particularly useful in scenarios involving multiple feature or measurements in a data frame. Okay, coming to the next topic is Glue dynamic frame versus Spark data frame. So since in my project we are using EMR cluster as well, and we are using Glue as well, so that's why the interviewer asked me, okay, so did you see any the differences between the Glue dynamic frame and the Spark data frame. So you can see these are the mainly difference for a schema flexibility. We have the integration with AWS services for both Glue and Spark, performance and optimization, and ease of use and the maintenance part. So basically Glue, they are optimized like for its dealing for the semi-structured data, and so they are basically optimized for dealing with semi-structured data or the data with evolving schemas, right? So but when we come to the Spark, so these require like defined schema upfront, and while Spark data frame can handle semi-structured data like JSON, the schema needs to be like inferred or explicitly defined at the time of reading data. Now coming to the integration with the AWS services, so as part of the ecosystem, like dynamic frames are like more easily can be integrated with the AWS services, and they work very smoothly like with the Glue catalog, S3, Redshift. It can be like the ETL operations are very much smoother with AWS Glue. While even Spark can be run on AWS with EMR cluster. So but we need to create a containerized environment, and it's not like the main difference will be when we are going with the EMR cluster. So we need to launch the EMR cluster. We will be having certain dependencies, orchestrations, all those things will be there. And with the AWS Glue, it will be completely serverless, And these days, like, people are more focusing on building like serverless data pipelines. So glue would be like very much beneficial, especially for the ETL jobs. But again, Spark has their own benefits. We can use apart from ETL jobs, we can use Spark for various other purposes as well, where glue will not be suitable. So yeah, this is about like one of the difference. uh, so coming to the performance and the optimization, we know like Spark uses the Catalyst optimizer for the better performance, especially like for any complex queries or transformations on the structured data. Whereas like in glue, so dynamic frames allows you for the dynamic schema resolution, which is also an advantage for ETL jobs, for involving data sources with any complex or like changing schema, like schema drift we will be having. We call it as a schema drift. So this flexibility like might come at cost of like some performance optimization, but this is a very like suitable technique where some data sets will be having the schema drift, or schema will keep on evolving in a period of time. So, and coming to the ease of like maintenance and use, the glue includes its dynamic frame is managed. We know it's a managed dynamic frame as a service, which it will reduce any operational burden of configuration, managing, scaling. Everything would be taken care by the glue. And basically it is built on a high level abstraction to simplify the ETL job. And coming to the Spark, basically it provides like more granular level of control over data processing. Like we can have all the manual control on the complex data processing side. However, like it requires like more knowledge about the distributed computing, about the Spark APIs to optimize and maintain job efficiently. So running Spark like at scale, typically it requires managing like clusters, which adds to the operational complexity. So you can provide all these like differences between the glue and Spark, and in which scenarios you will be using glue or Spark. Now, how Spark jobs are orchestrated in your project? Describe it with your data pipeline. So every organization will have their own data pipeline, and data pipeline keeps on evolving over a period of time. So I have given here one small example of data pipeline which we are using in my organization. So data is coming from the various sources. We can see here it can be like the database, or it can be from the web service. Data can come from any file system, in-house file system, and it can come through any streaming services as well. And we have application logs as well. So these are the kinds of sources through which we will be getting data. And so the data will be like, okay, so after that we will be having data ingestion methods. In data ingestion methods, basically its work is to like pull data from your source and dump it onto the landing zone of data lake. So data lake design can be there in the various ways. In my organization, there will be various sectors in the data lake where we are keeping the data, and that will be like controlled by the data governance. On top of it, Again, like data governance is a separate topic on which I will be creating a separate video. But here, like we can understand, there is a landing zone which is built on top of S3, and there is a publish zone. So the question is about the orchestration of your data pipeline jobs. So we are using like the Airflow for the orchestration. So initially at the first level, we will be using some of the data ingestion service for pulling the data from sources. It may be your data sync, like for transferring a large volume of data over internet or AWS direct connect. We can have Kinesis data firehose, like for loading any streaming data into AWS with ability to transform data and load into S3. We have SDKs. We can write our own. You can utilize AWS SDKs for various programming languages, Java, Python, to programmatically upload the data to S3 landing zone. So various techniques are there. You can use AWS Snowball, API Gateway, S3 transfer acceleration you can use. So various methods we can use to pull the data. It all depends on your requirement, how you want to bring the data. So data will be coming, the raw data will be coming to the landing zone. So, and after that we will be having so data will be extracted and will be coming to the landing zone. And then after that we will be running a job, basically a Pyspark job for basically it will extract the data from S3 landing zone, and it will apply the DQ and enrichment and any other pre-processing things. If in your organization has to be performed, it will be performing those things. And after that that job will load the data to the published layer. So in published layer we will be having like enriched clean data which is like ready to be used. And after that there will be an ETL job which will do the Snowflake load. So as part of ETL we may consume data from multiple published data sets. If we want to, based on your business requirement, what you are building, you can pull data from multiple data sets sitting in the published layer. So, and apply the transformation, and the final data will be loaded to our data warehouse is on Snowflake. So there will be so databases and the schemas and tables will be there inside that warehouse. Again, mainly for we are using our warehouse for mainly for the BI reporting, for machine learning purpose, and for data analytics we are using the data warehouse. So again, this coming to the warehouse section, it is a very vast topic. I can create a video separately on the data warehousing to show like what kind of schema we are using, whether it's a star schema or a Snowflake schema, and how we are creating the dimension table, fact tables for the reporting. So those things I will create a separate video on it, how the reporting are being done. So what are the parameters, all those things we can discuss in the separate video for data warehousing. And I will create a separate video on data governance as well. So yeah, coming to back to the orchestration with the Airflow. So we have data DQ and enrichment. So you can see the first, there will be two jobs basically, two Spark jobs. First is to extract data and apply the DQ and enrichment, and second is to apply the transformations and create the ETL job and load to the Snowflake layer. So this is a very basic example of a simple data pipeline. And these jobs, basically what we are creating in PySpark, will be orchestrated and in the Airflow. So this is the example of the DAG which we have created for our Airflow. So you need to define this DAG to manage this workflow. Each step would be like defined as a task in a DAG with dependencies like clearly stated so that tasks are executed in the correct order. Now here we can see so we have created all the tasks, you can see, right, whatever tasks I have just discussed, and we have to use the operator here. So we have the Spark submit operator and Snowflake operator. Using these two operators, we have created the tasks, and these tasks will be executed sequentially, and we can see the execution status in the Airflow dashboard as well. So, and deployment basically will be done through the CI/CD pipeline along with your PySpark code in the production environment. And yeah, and you can configure your you can schedule your job, or you can manually trigger it based on your requirement. You can do it. So thank you for watching this video. There are more topics left which I will be creating, which releasing in the very soon in the second video, and where I will be discussing all the leftover topics. So yeah, stay tuned.